Imagine a civilization so advanced, its energy needs are truly astronomical. They've outgrown every power source on their home planet, from burning fuels to harnessing the wind and splitting the atom. To quench their insatiable thirst for energy, they look to the one object that has always been the ultimate source of power in their solar system, their star. What if you could capture not just a tiny fraction of its energy, but all of it? Every single photon, every joule of energy radiating from its surface. This is the incredible concept behind the Dyson sphere, a hypothetical megastructure that would encase an entire star to harness its total power output. It represents a leap in civilization's capabilities so vast, it redefines what it means to be a technological species. The idea was popularized by the physicist Freeman Dyson in 1960. He imagined a civilization reaching a point where their energy consumption equals the total energy produced by their star. To achieve this, they would need to build a structure to intercept all of that stellar energy. But a solid, rigid sphere completely enclosing a star isn't the most practical design. A solid shell would be gravitationally unstable. Any small nudge, say from a passing asteroid, could send it drifting into its star, leading to a catastrophic end. It would also require an amount of material so immense that it would likely exceed all the planetary mass in a given solar system. So, the most plausible version of this concept isn't a sphere at all, but a swarm. This is the Dyson Swarm. It's not a single, solid object but a massive collection of independent, orbiting satellites. Each satellite, or habitat, would have vast solar collectors pointed at the star, absorbing energy and beaming it wirelessly to wherever it's needed. This swarm of collectors would move in a thick, coordinated dance around the star, forming a porous, non-rigid shell. The advantage of a swarm is its modularity. A civilization could start building it piece by piece, launching one satellite at a time. Each new addition to the swarm would increase their total energy capture, providing immediate returns on their monumental investment. It's a project that could span generations, or even millennia, growing as the civilization's energy needs and construction capabilities expand. So, how would a civilization like ours even begin such a colossal undertaking? The first challenge is sourcing the materials. Where do you get enough matter to build millions or even billions of large orbiting platforms? The answer lies in our own cosmic backyard. We would need to deconstruct an entire planet. The most likely candidate in our solar system would be Mercury. It's the closest planet to the Sun, meaning it has a relatively low amount of energy needed to move materials from its surface into a solar orbit. Mercury is also rich in iron and silicates, the very raw materials you'd need to build solar collectors, habitats, and the automated factories required for such a project. Disassembling a planet sounds like pure science fiction, but for a civilization capable of building a Dyson swarm, it would be a necessary feat of engineering. They would deploy legions of self-replicating robotic miners and construction drones. These machines would strip mine the planet, processing its crust and mantle into usable components. The processed material would then be launched into orbit using electromagnetic mass drivers, essentially giant space cannons flinging payloads into their designated construction zones around the Sun. The entire process would be a symphony of automated industry on a planetary scale. Once in orbit, other robotic assemblers would catch these raw materials and begin constructing the individual swarm satellites. Each satellite would be a masterpiece of engineering in its own right, perhaps miles wide. They would be equipped with massive, hyper-efficient solar panels, heat radiators to manage waste heat, and propulsion systems to maintain their precise orbits and avoid collisions with other swarm components. The swarm wouldn't be a random cloud, it would be a highly organized, intelligently managed system. A central command AI would likely choreograph the orbits of billions of satellites, ensuring a stable and efficient energy capture grid. It would be the most complex traffic control system ever conceived, operating on a scale that dwarfs anything we can imagine today. This swarm wouldn't just be a power station. The satellites could also serve as habitats. A Type 2 civilization, as they're called on the Kardashev scale, would have a population far too large for a single planet. The inner surfaces of these swarm satellites could be turned into artificial worlds, with their own ecosystems, climates, and cities. Living inside a Dyson swarm would be a fundamentally different experience. There would be no day or night cycle dictated by a planet's rotation. Instead, daylight would be a constant, managed by the structure itself. The view wouldn't be of a distant, star-filled sky, but of the intricate, glowing lattice of the swarm and the blazing star at its heart. Now for the big question, have we ever detected a Dyson swarm in the wild? If a civilization were to build such a structure, it would leave a very specific signature. While the swarm would block the visible light from its star, it wouldn't make the star disappear completely. The laws of thermodynamics are absolute. The energy absorbed must be radiated away. The swarm satellites would heat up from absorbing the star's energy, and they would need to radiate that waste heat away to avoid melting. This waste heat would be emitted as infrared radiation. So, an advanced alien civilization using a Dyson swarm would transform their star from a bright point of visible light into a massive source of infrared light. From a distance, it would look like an unusually dim star that is glowing brightly in the infrared spectrum. Astronomers have been searching for these telltale signs. Projects like the SETI Institute and various sky surveys have sifted through data from telescopes, looking for objects with these unusual heat signatures. One of the most famous candidates was a star named KIC 846-2852, also known as Tabby's star. This star showed bizarre and extreme dips in brightness, at one point dimming by over 20%. This led to a flurry of speculation. Could this be a Dyson swarm under construction? An alien megastructure partially blocking the starlight? However, after years of further observation and analysis, the leading scientific explanation is that the dimming is likely caused by a massive, irregular cloud of cosmic dust orbiting the star, not an artificial structure. While disappointing for alien hunters, it was a fantastic exercise in scientific inquiry. To date, we have not found any conclusive evidence of a Dyson swarm. The sky is not filled with giant infrared orbs. This could mean a few things. Perhaps no civilization has ever reached the level of technology required to build one. Or maybe they are incredibly rare, and we just haven't looked in the right place yet. It could also be that advanced civilizations find more efficient ways to power themselves, or they choose to limit their expansion for reasons we can't comprehend. The construction of a Dyson swarm represents the ultimate act of cosmic engineering, a civilization taking control of its destiny by harnessing the full power of its star. It's a breathtaking concept that pushes the boundaries of our imagination. It serves as a powerful reminder of the potential that lies ahead for a technological species. While we are centuries, if not millennia, away from even considering such a project, the idea itself inspires us to think big. It encourages us to look up at the stars and wonder not just what is out there, but what we might one day become. The dream of the Dyson swarm is the dream of a boundless future, powered by the very heart of a solar system. Thank you for joining us on this journey to the edge of imagination. If you enjoy exploring the biggest ideas in the cosmos, be sure to follow Space Repo for more.